开这个日文。反正yeah, today we are going to like introduce like what's computer vision, like why do we need computer vision, like what is computer vision, like why do we use deep learning based computer vision, and then like what is machine learning and deep learning. Do like a brief introduction of like Python, and just like also like a brief tutorial of like practical application of uh, deep visual recognition, like image recognition using PyTorch. Then how to do like research, like some tools and some tips, and then like a guided tutorial on um, how to read research papers. So about computer vision. Uh, So why do we need computer vision? Basically, this is like a graph of like academic publications. We can see that it has been growing like quite a lot in the last few years. So there's a lot of like academic interest. And there's also like a very like large market for computer vision worldwide. So there's a lot of money in computer vision. So why actually like in terms of applications, we can see like some interesting applications of computer vision here. Like this is like text to image generation. 完形生成图像. This is from actually it's kind of old at this point. 这是2020年的 DALL-E 是 OpenAI 的一个软体。然后 you can see like basically you like take some like text and it's going to like generate like some like images, and it's like very interesting stuff because you see this is like a chair in the shape of an avocado. So this is something that you cannot um like it's basically like very unique because you cannot expect that to actually exist. And this is like that's 已经是算是2020年的，所以这个已经有一点久。现在他们已经有发出 DALL-E 2，所以其实这个已经还有 DALL-E 2比 DALL-E 1算是蛮实用的应用。然后当然，另外一个是那个自动驾驶的汽车，然后 like probably like Tesla and a lot of other companies like Toyota, and basically I think basically every like car manufacturer is like investing in this. And usually like one of the building blocks for like self-driving cars is building like something like a model for the car to actually recognize the word. The way that we do that is sometimes something like this that we call segmentation, um, that I will talk a little bit about later. Then you also have other things like medical image analysis. Uh, Here you can see like for example like some X-ray, and you want to detect like some like disease like pneumonia or COVID or something. Uh, but there's also a lot of other applications for like computer vision for medical usage. 然后还有什么 like 农场的应用，比如说 like some like disease control or some like problems like due to like drought, like lack of water, or some problem like with like when do you need to harvest, like okay, like 这些苹果都已经看起来已经比较熟，so 我们要 like prepare them. So these kind of things are all applications of computer vision. Then aside from that, from like industrial point of view, you have like industrial automation that you can see in here. Basically, you want to like automate the process of inspection, of let's say making sure that whatever you're producing is um, okay, like it's working. So you can also like use like machines like okay, that have like lenses to like inspect like whatever you're producing. So that's another application. And then this is probably the one that I'm interested the most in. Uh, this is supposed to be a video, but it doesn't play. But yeah, like basically like multimedia generation. Like all of these images, they are like AI generated. So if you like look into the details, maybe you will see like weird stuff. Like for example, like some eyes, they look kind of weird or something. But in general, there's been a lot of progress in this area, and we think that in the future it will help a lot, like to simplify the creative process for like artists and people working in creative industries. Oh yeah, there's the video. So here we can see like how we can use this as a tool to like do interactive editing of like any kind of character for like video games or like anime or anything like that. And then you also have other applications like, for example, like image denoising, image super resolution, image in painting. These are all like applications of computer vision. 最近我已经谈到就是一些电脑视觉的应用，我现在要给你们介绍，那 computer vision 的 definition 到底是什么？所以我们可以简单说是 like，这是我在一门课就是那个老师给我们介绍的。It's like basically you want to give computers the ability to see and understand the contents of images and videos. 所以他先会给我们说，我们看的世界就长这样子。Like we can see like some like shapes, some colors, some anything. But for computers, it's just like basically a matrix of zeros and ones or certain like pixel values. So the way that computers look at the world is fundamentally different. But what we want to do is, okay, based on these numbers, to still recognize the same thing that we recognize here. Like, for example, this is like a picture of a train or like a building or something. Or in this one, like, okay, we see like some fruits and we want the computer to say, okay, there's like a bowl of fruits, like, okay, like orange and banana and peach and apple into like one single uh, yeah, like we want, that's what we want the computer to understand, just like we do. So there's a lot of tasks in computer vision, but these are probably the most common ones. uh, Basically starting from, okay, classification. If you are given like an image, we want to predict like what category the image is. So basically, for example, in this image we can see there's like a horse, there's a person, there's also grass. If you look at the back, there's also like a car. Then there's also like detection, like 检测, usually object detection, like 物件检测, where we want to like not only predict like what are the classes, what is like the categories, but we also want to give some boxes for, okay, where is the object. So in this case, this is a person, this is a car, this is a horse, and so on. Then segmentation, uh, which is basically, it's kind of taking detection a step further. Instead of just giving like a box, we want to like predict like pixel by pixel, okay, where is like the person. So here we can see the shape of the person, or here we can see the shape of the car, the shape of the horse, and the rest, okay, we say, okay, this is like background. So it's basically, yeah, baiting any something else that is not in any of the other class. But then aside from that, we other have other kind of tasks that are more complicated, that are about like getting a higher level understanding of what's in the picture. Like for example, like uh, describing like what's in the image. It's like 图像描述, or 影像描述. Basically, okay, we are describing, okay, what's happening in the picture, like a person riding a horse in a field, or like visual question answering. So if we ask question like how many cars are there in the picture, we can say, okay, there's 1, 2, 3 cars. or like what color is the horse, and we can say the horse is brown. And then finally there's like, okay, more even higher level task, like, okay, make a story based on the pictures, like, okay, or make some extra like comment about what's happening in the picture.呃，then 我已经介绍好的，就那个简单的电脑视觉是什么。然后下一个是，最近我们都在使用深度学习做电脑视觉，然后原因是为什么？是因为应该是从2012开始，AlexNet basically they won like a very important like computer vision competition, like the ImageNet competition. And after that, basically people recognize that, okay, basically deep neural networks, they can outperform like traditional methods for feature extraction, which I describe here. It's like basically something like called like SIFT surf. I'm not going to detail what's this, but we can say that these are like traditional methods for feature extraction. Uh, 特征地区的传统演算法. And usually in the past, people would use these methods and then combine them with traditional machine learning classifiers, something like support vector machines, SVMs. But then after 2012, everything changed, and now people use deep neural networks, in particular CNNs, for quite a lot of like computer vision tasks because they can automatically learn like what the feature descriptors and machine learning classifiers were doing in a single step. Um, so this is like just a brief aside. It's a very interesting read that I suggest you to read. I included like a Chinese and a like English like version, so you can like take a look at it. But it's called like the Bitter Lesson. It's written by a professor in reinforcement learning called Richard Sutton. And the Bitter Lesson is that like general methods that level computation are ultimately the most effective. Uh, Basically, what it's trying to say is that um, like things like learning and search, which are like two kinds of method that scale with computation. Like basically, if you have like larger like computer resources like GPUs or TPUs or any kind of like accelerator, and you have like enough data to combine with these methods, basically it's going to get better results in the end. And like that's kind of like the general idea of, okay, why did this AlexNet network in 2012 they won. But there's also like a few other like examples of that, um, including like the first time that like a machine won in chess and in another game called Go. Basically, like here you can see like chess based on deep search. Was in 1997. It's called like Deep Blue by IBM, and they use like a deep search method, and it was basically like a very like big thing a lot of years ago. Then this one is much more recent. You probably know it about. It's uh, like Weiqi, like it's like made by DeepMind, and it's called AlphaGo, and it won against like the like at that time the Go champion Lee Sedol using like some uh, deep reinforcement learning and self play algorithm, and like yeah, that was also like a very like big thing. And then, as I mentioned, like originally we would use like SIFT like traditional features like that are we call them like SOCOM because basically you are designing like a feature extraction method yourself. And then after 2000 in the past that was like 2010 2011, and you can see after we changed to deep neural networks, we can see that changing to deep neural networks in this case AlexNet, it reduced the, this is the图像的别人的标准图. Basically, it reduced that like error rate by quite a lot. And then as we increase like the amount of computation, basically we keep getting like better and better results. And that was kind of like, it's like the core idea behind the bidder lesson. Finally, like then for natural language processing, like 自然语言处理, basically we can see kind of like same story. Originally it was based on statistics, but recently it has been replaced by very large deep neural networks called transformers. Um, so for example, like even Google, they begin using like transformers for their search engine because it's better than traditional methods. Uh, and I think I would like introduce a little bit about transformers, but probably we'll leave that for another day. But yeah, like the thing is that transformers are like something that is very, very popular right now in like deep learning and machine learning and computer vision and natural language processing. So I think I would like to introduce that, but another day. So okay, now I kind of introduced to you like uh, some of the advantages of deep learning, but before going into deep learning, we need to know like what's machine learning, like this is strategy. And basically, okay, so this is like a definition that I like. It's basically you're providing a system with the ability to automatically learn and improve from experience without being explicitly programmed. And okay, there's a lot of words here, so let's actually mean what does it? How can we actually like see that in practice? Basically, we have like in the case of like image recognition, we have images, and we have like some like okay, we have some task which is recognizing if this is a cat or it's not a cat. And then the experience are the images. The task is like recognizing the image, and the we have a performance measure, which in this case is like the 图像的辨认标准图. Um, and basically, if the program is like not, if it's like not getting, if it's not getting like the right classification of cat or not cat, basically it will use that experience to improve. And that's the kind of idea behind all machine learning algorithms. The way that this usually happens in practice is by using some sort of like a gradient descent optimization. But I won't go into the details of that. But yeah, basically the idea is that okay, you are giving it some images of okay some task, some examples. In this case, like pictures of cats. You have a task predicting like cat or not cat, and then you have some performance measure. And basically, based on this performance measure on this task, it's going to like keep like improving. Basically, uh, that's the idea behind all machine learning algorithms. But deep learning, it's kind of deep learning is a subcategory of machine learning. The difference is that in deep learning, we use like what we call like deep networks with multiple layers. So basically, like that's like the keyword. Like you're using multiple layers, and we also have like the idea that in deep networks, like bigger is better. Like more computational resources, more like it's yeah, more data. Like these are the two like big things behind deep learning. Um, so again, we have like two images of like a cat and a dog, and we want to predict, okay, is this a cat or is this a dog? And if it predicts correctly, then there's no problem. If it doesn't predict correctly, then it's going to like use some gradient descent optimization to adjust like this network, which in the end it's just basically a bunch of like numbers, like what we call parameters, that it's doing some sort of matrix multiplication to basically do a better prediction next time. That's kind of like the general idea behind like deep learning. Uh, then like deep learning has become very popular in the last few years, but there's actually a few reasons why that has happened. Like the first one is because there has been like some very good like software frameworks. Uh, like for example, like in 2000, 2000 early 2000, 2010s, there was this Diano. Then in 2015 we have TensorFlow. In 2016 we have PyTorch, and there's been a few other like deep neural network frameworks, and that has kind of facilitated the process for people to experiment and try out this field. Then another one is like basically like big data, big label data sets. Like we can see, like for example, ImageNet. It was kind of like a big important, like it's still a big important data set for machine learning, for computer vision, for image recognition. And probably all of the improvement that we have gotten wouldn't have been possible without these like large clean data sets. And also important, like they are open so everyone can use them. Then there's been like some improvements like in the algorithm itself, um, but I think that's kind of minor. And then there's finally like some improvements in hardware. Basically, in the last decades, there's been a lot of advancement in like GPUs. They have been advancing very, very quickly. And even now we have like Google, like they released their own accelerators for machine learning TPUs. And there's also a lot of startups like doing work on producing like better like hardware accelerators for machine learning and deep learning. So hardware is a very important reason. Okay, now let's go back to like the problem of using deep learning for image recognition. Uh, as I said in the past, what we would do is we would do some like the traditional recognition would be something like we design some manually design like feature extraction and description. Uh, and but now what we are doing is we are letting the neural network to automatically learn the feature extraction. Basically, it's like automatic feature extractor. So again, we have like some image, and then we can like think of like the pixels of the image, like each value in the image as an input, and then we can take those as features, pass them through like a few layers of neural network, and then basically predicting like some category. As we said in the past, like something like cat or dog, something like that. Uh, and then in the past, we would like directly design some method for designing like we want to like find some edges, then combine edges, then combine the features, and that's what we did originally with like traditional methods. But now when we are doing deep learning, actually we can think about it also as a black box. You are putting some inputs in and you're getting some outputs out, and that can be a problem because we don't really know what's happening in here. Actually, we do like to say we do like to say that we design our particular architecture that has some particular way of doing stuff, but in general, like the exact details of what's happening, it's still like mostly like a black box. So that can be a problem, and there's a lot of like work on like trying to explain what's happening inside of a deep learning model. But that's also something that you need to take into account. Basically, we put some inputs and we get some outputs, and pass them through a black box. That's also another way of looking at deep learning. So, well, with that in mind, basically, I think I have already introduced to you, like why is deep learning important, and like why is it important for computer vision. Because this is like a very like short introduction, I cannot go through all of the details, and there's a lot of questions regarding the details behind machine learning and deep learning. That if you are interested, I recommend you take this this course. I included the links in the slides. It's called like deep learning and specialization. It's given by a very famous like Stanford professor, Andrew Ng. And basically, this course is going to cover a few topics like what is machine learning and deep learning, like then like some basic concepts of okay, like what's supervised learning, what's unsupervised learning, then like kind of okay, two big problems in machine learning, which are regression, frequency, and classification, Fenley or BNREN in the case of images. Then you also have like some like very basic machine learning algorithms like linear regression and then logistic regression, and then two like big problems in machine learning and deep learning that are like uh, underfitting and overfitting. So these are like all things that are like basics about like machine learning that probably it's better to just take like a course. This course is like very like simple, but at the same time, I think they explain all of these concepts intuitively. Um, the course is in English, but it has Chinese subtitles, so it's I think it's good. This is was the one that I took in the past when I was learning about this, and I think yeah, it covers all of these things like very well. Then the next thing is like about deep learning in particular, like what are artificial neural networks, and then like different kinds of neural networks, like fully connected layers, then softmax layers, and then like different kind of activation functions, like what's an activation function, and then finally like what are convolutional neural networks, uh, and then like what's a convolutional layer, and another important layer in convolutional neural networks that are like pooling layers, and then finally okay, how do we use CNNs for image classification. So these are all like questions that are answered in this course. But I think probably like most machine learning or deep learning courses will cover this. The difference why I recommend this one is because other courses that I have taken, they can become too theoretical and you are going to spend a lot of time like okay, maybe deriving um like okay, how do you define like this logistic regression and some loss function. Uh, the point is that it's very easy to like get lost. There's a lot of material, a lot of things that are not particularly relevant. So I think like this is a course that it's structured in a very like short way. Basically, like it's like each lecture is like 5 minutes or 10 minutes. So it's hard. It's easy to keep your attention. It's easy to keep focused. And basically, it should like kind of give you a rough idea of what are all of these things. Of course, 如果你们想要多理解机器学习、深度学习，我们学校有很多课程但是当然就是要花比较多的时间，因为他们大概会让你做很多作业，然后学很多理论。那个理论我有时候自己觉得不是很有用，因为很多我觉得已经有一点 outdated，而且另外，如果你比如说你要做一个应用，比如说呃图像辨认，还是你要做图像生成，我知道他们在传统的机器学习的课，他们会就是会学到很多你从来没会用的一些知识，那是我的意见。Anyway, like as I said, I wanted to keep this practical, so I will go a little bit about Python. So why do we use Python? You can see that okay, it's basically very simple. This is like a basic hello world in different languages, and we can see okay, like in C++, like you need to like do some includes. Then in Java, you always need to use classes for everything. Then Python is just very simple. It's like writing almost human language. Then it's very easy to set up. Um, like basically, there's many online options like Google Colabs and Kaggle kernels. I included the links here. but there's a lot of ways to actually run Python online that are very convenient and for free. Um, so I think that's another like important reason. It's very easy to like set up. Then it has a lot of tools for interactive visualization and for data analysis. So for example, like these are called like Jupyter notebooks. It's kind of like similar to Google Colab, just that Google Colab is online and Jupyter notebooks are not online. I included a tutorial here of how to set up a Jupyter notebook in your machine and how to like set up like a Python environment in your machine in case you want to like try it. But basically, the reason why we use it, it's like there's a lot of tools for like doing like plots and like doing data analysis. So it's very convenient. And then Python, like another like big advantage is there's a lot of open source libraries. We have like here are like some things for like deep learning. Then you have NumPy, which is for scientific computing, Spark for distributed computing, NLTK, Uyensuli, Scikit-learn, GCSWSI, Pandas. It's like tabular data. So and there's a lot of like the other like libraries for like uh, I don't know, a lot of things basically. Um, and then if you would like to learn Python, I suggest you to take this little course that I included here in the links. It's like a very short course of how to use NumPy, which is a library for doing linear algebra. But basically, it covers like all of these things. Okay, how to set up the environment, basic data types for like Python, like okay, like container data types that we use in Python, then like functions in Python, classes, and then the most basic libraries that we use, like NumPy for linear algebra, how to use NumPy, then SciPy. It includes a variety of tools for scientific computing, and then Matplotlib for like plotting. And then in case you are interested in other things, there's Pandas, which is for tabular data, like things like Excel, and Scikit-learn for machine learning. So I included like the links for all of these in these slides. Um, then okay, based on that, now let's go to the tutorial of like okay how to like do visual recognition with PyTorch. Uh, Ideally, again, if you want to like understand this much better, I suggest you take this tutorial, which it takes probably like around like 1 hour, and then I suggest it's like the best way of learning, like learn by doing, and it's like very practical. It includes like okay how to like what are tensors, and then like what's actually happening, what why is PyTorch like the core behind PyTorch, which is the auto grad function, like it's basically to compute like derivatives of functions, which is very important in case of deep learning. And then like okay how do you make neural networks using PyTorch, and how do you like use that for like doing image recognition, and that's a tutorial. But today I want to like go with a practical example of like my application that I have been working on, so that you can actually see okay how do you put all of this together into like some like source code base for doing image recognition. Um, so in the past I had been working on this like anime character recognition, like 动画角色的辨认. And basically, this is kind of like very similar to the code that I use in my experiments. So it's in it. I think it has basically most of the things that you need to like do like deep learning research, or at least to start doing deep learning research in this area of image classification. And I included the links to the this project um, also below. So let's look at the directory of how do I organize my projects in detail. basically we have like a few folders, like you can see like configs, data, pre-trained bit, tools, and then some like setup, like basically like I guess you all know like what's a git ignore, but if you don't, basically it's related to git, and git is a file management system for like no, it's not a file management system. It's basically for like a file versioning system. Yeah, file versioning system. For like keeping like different versions of your code and then host them online. Then like this is just for like the purpose of describing your project. Um, then this is for uh, yeah, this is for basically including like packages that this project requires, because as I mentioned, Python uses a lot of packages, so we can like include the packages that we need so that if people are going to use this, they can easily install this project. And then this is related also for the installation of this project like as a package. And finally, like this one is it's used to like download pre-trained models that we use, because I think interesting about like image recognition is that most people they actually use like deep learning models that are trained on very large data sets, and that they can then uh, share with others, and that has some advantages compared to like training from scratch. uh, so basically like that's the way that we usually like do like image recognition. Like you would train some model on a very large amount of data, and then you would like adjust it, or what we call it fine tune it for a particular task. In my case, my particular task is anime character recognition. So this part is basically downloading the original models that were trained on a larger amount of data, more amount of general data. So about the like particular folders, basically the first one is like configs, and basically I use it to like keep track of like okay the experiment settings. For example, like the data set that I'm using for a particular experiments. So for example, this data set is called Cypher 100, or this data set is called uh, Coop. It's about birds. And basically also like other things like the particular settings of like the network that I'm training, like the image size, like another parameters that are very important for like deep learning training, like what we call the batch size, the amount of epochs. Epochs means how many times I'm going to like go through the data set to train my network. And there's also like other parameters like the optimizer that I will use, which also affects like the training, and then other particular details related to the optimizer, like warm up or wake decay, that I don't think I can explain in detail. But basically, what I want is to like make sure that I keep all my different like parameters of my training parameters in a way that is like easy to follow, and if I need to change something, I know like okay where to change it. Then as for the data itself, I have like basically I work with different data sets for different tasks. That in, for example, like this one is like aircraft, Fiji, Cypher includes a lot of different categories, um, like boats, cars, dogs, cats. This one is only for birds, and these two are only for like anime. And they all follow like a similar structure. Like basically, you would have like for each image, you have like the directory of where each image is, and then you would associate with each image one class ID. So for example, okay, you can say this is an image of a cat, and then all of the images with class 0 is a cat, all of the image with class 1 is a dog. Um, so yeah, that's kind of like the general idea behind like these label datasets. Basically, each image, like where they are, and what kind of image, what category they are. I already like told you like basically you're using this to like download some pre-trained models, and then like this is for like installing the package. Then there's also like this other like folder called tools where I put like the things that I use for training and for doing inference. I will describe that in later in more detail, but here's the basically the general structure. Like in train, it's basically the whole like loop for like doing the training of the neural network model, and then inference is for when I want to like do some prediction, use my train model to do some prediction of okay, what class is this, and then here's like a few like auxiliary tools for different uh, other things that I need to do that are probably I don't need to like describe this in detail, but basically like a few other like small things that I may need to do. So let's first go through like the inference, like what's the inference? So inference is about like as I mentioned, making some prediction. And here's like an example of how would you use it. Basically, you can point at like some folder with some images, uh, and then like choose like a model that you want to use for prediction. And then in this is like the Python file, and I like describe okay basically what is like each group of like lines doing. For example, the first 10 or so lines we are doing some importing some packages. The first ones are all like part of like the Python like standard packages, and then the second group is basically packages that are like non-standard that you need to install before running this, including like Torch, PyTorch, and Torch Vision, which is like another like package from PyTorch that is specifically for computer vision. And then you have this PIL, which is for like doing image loading. And finally, then you have this model, which is the one that like I'm using. That it includes like the model that I'm using and some configuration file. So the first thing that I'm doing is that I want to prepare my image because as I mentioned, like computers don't look at images the same way we do. So we need to like put them into a way that the computer can take the image in. So in this case, the first thing is like making sure that the image is an RGB image, because if it's, let's say, a grayscale image or another kind of image, it's not going to work. So we need to make sure that the image is like RGB image with 3 channels. Then we want to make sure that the image is the resize to the size of the model that you train it with. So in this case, we want the image to be like, let's say, a square of 224 times 224 size, but it can be any size depending on the model that you train. Then after that, originally this would be in a different file format, so we want to make it into a tensor that can be used with like PyTorch. So we make it into a tensor, and then finally, because like an image usually is like an array of like values from 0 to 255, uh, which are like pixel values, because it's 8-bit images. We want to make them into like a float value, because all of these operations are designed to work with floating point values, and we want to make sure that the image is normalized instead of being so that the mean and the standard deviation are 0, so that the image has like mean 0. So what we do is like, okay, we normalize the image. So that's what the first part of this like script is doing. Then the second one is I want to like find the images that are in the path that I gave it. So I can have like a path, for example, called samples. And then in this path, I have one image called like sample1.jpg and sample2.jpg. So I'm looking for the images inside of that folder recursively. And then I'm looking for files that have like these extensions, which are all like commonly used image files extensions. So that's what the second part is doing. Then the third one, basically, I am loading the model. So I'm creating like a model, like in this case, it's called a VIT. I will tell you what's a VIT later, but it's basically the model that is going to do we can think about it as the black box that is doing the prediction. So I am loading it into the program. And then after that, I'm loading the classes that I'm working with. So if I have, let's say, two classes, it will be like cat and dog. But in this case, I have 1,000 classes, including things like dog, cat, bird, car, and so on. Then I want to like go through all of my files, and one by one, I'm going to prepare them, and I'm going to make some prediction. I'm going to pass the image through the model, as I mentioned, like a black box. Basically, okay, the model is a black box, and then I put the input, my image, and then I get an output, which are probability distributions. So I can like, okay, then print those predictions, like print those outputs to show basically, okay, this, for example, this image is a dog, or this image is something else. Then finally, like in here, it's just like the part where I take the input arguments, including like the image path and the model that I'm going to use. So that's kind of like related to inference. Uh, then the core of like doing like deep learning would be like doing training. Like, okay, you train a model for a particular task. And it's actually okay, it's composed of a few like different parts. The first one, like you import some packages. Then in this case, I am like setting up like my results for in case like, okay, I'm saving my results and I'm putting them into like a particular directory. Then because in deep learning there's a lot of like randomness, so you want to like set the random seed so that there's as less randomness as possible, because you want to be able to reproduce your results in case you need to. Then after that, you will need to prepare the data that you're going to be working with. In PyTorch, we use something called data loaders. So we prepare these data loaders, and then again, you prepare the model, the black box that you're going to use based on some particular configuration that you will use for this case. Then this is only used when you're using like multi-GPU. So it's just about like, okay, some particular settings of multi-GPU training. Then, as I mentioned, like, okay, the important things in a deep learning model are like the data and then the task. So in this case, the task we can describe it as, or the way of evaluating the model, we use what is called like a loss or cost function. Um, and then the loss and cost function, basically, it's going to give the guidance to the model to be able to learn. In this case, basically what we are saying is, okay, if the model makes a wrong prediction, then we are going to penalize it. We are going to increase the cost. Then if it makes the right prediction, there's no problem. So we want to make sure our model is making the right predictions, and that's what the cost function like is basically helping with. Then how do we actually do that is by using an optimizer, Yohachi, and then that's related to like the actual like training of how do we actually adjust the model As I mentioned, we use what we called it some sort of gradient descent in some way. Uh, and then basically the optimizer is in charge of like taking care of this. Then again, this is like something related to like optimizations for CUDA. And then this is for taking in the training input parameters. Something like, okay, like the learning rate or the model that we are going to use or any other settings. And then finally, like, then I would like wrap all of these things that I just loaded. I will put it into like a class. And then finally, like, I will like make the class, like basically like uh, go through take all of the images, uh, output some prediction, and then based on those predictions, optimize for this loss cost function, and then do it like multiple times. So that's why there's like some uh, like training and evaluation loop. Finally, then you like summarize your results. In my case, I will care mostly about like to champion and and two, but there's also like other metrics, like for example, like number of parameters, how long did it take for training, uh, and floating point operations, these kind of things. Finally, as I mentioned, okay, this is the last folder. I am using from here. I'm taking basically a lot of like different like functions from the main from different parts of this package. Basically, some of them are related to like the data preprocessing. Some of them are related to the model itself. Some of them are related to the input arguments to the model. And then finally, the training related stuff like the training loop and the evaluation loop. They are all like into these like different subfolders. But again, I cannot like go through this in detail. In case you are interested, you are welcome to like ask me any questions or send me a message. I can describe to you like what each of these, or if in case you're interested in any of them in particular, I can describe to you, okay, what's happening in each of these. For example, like what's happening in here, or what's happening in here, or what's happening in here. I can describe to you that in detail. Um, so for now, let's just like leave it until here, and let's take like a 5 minute break um, until like 2:05.